I'll quickly pass it on to Justice and team for the FRM report and demo. Justice.
Hi, Simeon. Thank you very much. Greg's got a presentation for us. There we go, Greg. Thank you. Welcome back, everybody. Moduloop Fraud Risk Management. This is actually our anniversary. So we were here exactly a year ago with the very first PI. I know there had been some groundwork done before that, but I have now been on this project for about a year. We started off in December of the year before. Greg, next slide, please. And today we're going to just take you a little bit through some of that background for everybody who might be new to our presentation on our work stream. And then we're going to talk about a proof of concept that we're very excited about. The team has been working really, really hard, put a lot of effort into standing up a fraud risk management solution out of exclusively open source components over the last 3 months. It's been a phenomenal effort, and that you'll see the fruits of that during the proof of concept part of the presentation. And then finally, we're going to talk about what's next for us. We have some next steps lined up for the next PI. Right. A little bit about our history. So as I said, we were here a year ago, and we started off doing a business requirements document that was commissioned by the Bill and Melinda Gates Foundation to draft business requirements for fraud risk management as an accompaniment to a Moduloop Hub installation. We did a number of deliverables at the time. We looked at the data, compiled the data dictionary. We compiled some high-level metrics and KPIs and dashboards. But the work that then continued into the next stream as we focused on it was the business requirements, and we expanded on that in the next work stream with a strategic alignment between the fraud risk management solution and a Moduloop platform. And we also invented at the time what we call the APRICOT model. So the APRICOT model has now been around for about 6 months, up to a little bit over. And that model was something we designed to classify fraud risk typologies. We'd initially identified 232 typologies, but they were very difficult to ingest in the way that they were presented. So we provided a classification model that would allow you to sub-select some of those typologies as they would apply to a specific environment, such as a hub environment. So we identified a number of typologies that were solely the focus of a hub operation. In the subsequent PI, we drilled down on that a little bit more, and we added to the APRICOT model a number of typologies that were exclusive to the hub, dealing with internal fraud or fraud that could be perpetrated by the hub employees, for example. In addition to that, we started planning for a PoC, and the PoC then became the focus of our current program Increment. So that's what we've been working on for the last PI. Just as a reminder, so when we started looking at the strategic objectives of a fraud risk management solution, we identified a number of potential configuration options for a fraud risk management system. The current one that everybody is, as we see it today, is a distributed model where all of the participants around the hub have their own solutions, and some people may not have a solution, but it is up to each of those individuals to determine. I think we may have lost the presentation. I'm just going to share it up on my side. So each of those entities around the hub would then have their own fraud risk management solution, and they would be obliged by their own regulators to conduct whatever regulatory processes have to follow on from fraud risk management and detection. The embedded model, we proposed that the hub would do fraud detection, and then it would farm out the results of that detection to their associated DFSPs, and the DFSPs would then perform their management functions as they are mandated. The difference between that and the next option, which is the semi-attached option, is in the embedded model, if you're not part of the hub and you don't send your transaction through the hub, then you can't actually have your transaction screened for fraud. That seems fairly obvious, but we did identify a blind spot in transactions that are on us or are part of point-to-point agreements between different DFSPs. So we added to that the semi-attached model, which separated the fraud risk management from the hub just a little, where all of the hub transactions would be reviewed by the fraud risk management solution, and it would also then be capable of taking out transactions from the DFSPs. the responsibility for managing the outcome of those transactions and the determination of fraud related to the transaction would then still be the responsibility of the DFSP. And then one more step further, there was a very extreme form of an implementation where a fraud risk management operator could potentially run an outsourced operation on behalf of the hub and any number of DFSPs. And they would then not only do the fraud risk detection, but also the fraud risk management. They would investigate the alerts, they would send notifications or reports onto a regulator that needs to be notified. And that would then be part of an ecosystem that may or may not be operated by the hub operator themselves. The reason we wanted to remind you of this is we focused mostly on the semi-attached model for the PoC. So the architecture that you're going to see would be an expression of the semi-attached model. From a context perspective, our scope for the PoC was to look at how a data interface would be constituted. So all of the transactions has to come into our system somehow through that interface. And then we would monitor all of the transactions through the system against a number of typologies and the rules associated with those typologies. And we would be able to do block list management where you could block a transaction potentially. And we would also then detect fraud and money laundering in those transactions. The alert and case management was out of scope for us for the PoC. We didn't want to include that. Our view is that the alert and case management is fairly mature as an open source technology. It's been around for a really long time, and we would rather have focused on new things that hadn't been done before than trying to tread familiar ground. The context of our solution, just briefly here, as I mentioned, we are focusing on the semi-attached model. So the customer belongs to the DFSP and interacts with the DFSP either through agents or through some sort of wallet or account mechanism. The DFSP is the host for that accounting information and account instrument. But for it to transact with another DFSP, it would need to do that through a switching hub such as Mojaloop. Mojaloop then passes the transactions from one DFSP to another and makes sure that the transactions are fully settled at the end of the day so that everybody gets their money and nobody is at a loss. Beyond that, we want to supply that data interface where a switching hub or even a DFSP could submit transactions through to the fraud risk management system that can then do the transaction monitoring, the list management, fraud risk detection, money laundering, and alert and case management. And I'm now going to hand over to Greg, who's going to take us through the architecture. Greg, do you want to take over the share?
So, okay, first off on the architecture, what I want to make sure I stress is that this is a PoC. This isn't a definitive architecture. This is things that we have worked with in the past, knew that worked, specific design patterns that we liked. We looked at how do we combine some different things, and we also looked at a couple of things that we'd kind of all been wanting to try. So just keep that in mind as you look at this, because some of the stuff we tried was ruled out of hand, but we still want to mention it to you. So this is the proxy model. And the idea behind the proxy model was that we stick a proxy server in front of the hub, in between the hub and the DFSP, and kind of like an F5 or a proxy server that's advanced enough to be able to pick up a message and modify it. We pick up the messages, we run what we need to run, and then we pass back the appropriate message, the appropriate addition to the message. But we ruled this one out pretty quick. It's still interested in some circumstances, but not really in the Mojaloop. The next one is the gateway model. The gateway model works really the same way. The difference is we literally would take the pre-existing gateway that's been built for Mojaloop, and we would take a copy of that, modify it, stick ourselves in the middle of it, and then place it in advance of everything else. That's obviously very complex. You know, some people like that idea, but we also, frankly, quickly ruled that one out. Where we started to get things that were a little more interesting were what we were originally calling the intercept model, but we changed the name to streaming model. Intercept gave you know, kind of bad connotations. And the way this one works is, quite frankly, you pass to us, to our engine, the information that we need to make an assessment. We pass you back a response. But the reason it's a streaming model is that it actually runs from within the hub, right? So you determine, the DA and everyone would determine where they want to make the call or where it's appropriate to make a call to us for a given thing. So like if we're checking something based on what happens in the account lookup service, or we're checking something based on what happens in the quoting service, the central service, etc. It's a relatively simple process. It's almost just like making a complete call out or a complete disconnect, but it's really not. It's much more connected inside. So for example, if we were checking typologies that had to do with internal user fraud and things like that, it might be something that makes sense to run on the inside, but this would need further discussion. Also, I have a note up here to interdict or not. So are we stopping a transaction in real time? Other systems will need that. Regulators want it. But the modular loop model is it completes, fails, times out, etc. So there really is no interdiction or a hard stop with the model. And so that's something that needs to be discussed. We did talk to some people that were interested in being able to do that. And I know there are others that really don't want to do that because they're trying to keep the switch clean and keep it out of the picture and let those types of things happen at the DFSP level. The next one is just a slight variation on that. The only difference is it's all REST APIs. So the interface points are in orange. The DFSP would make a call. We would basically go through all our work, and we would pass. They would either call back to us, depending on what it is, or they would deal with a webhook or something. That's yet to be determined as far as for real time. But notice there's a case management box in the upper right. Everything gets logged to case management. So not everything is a real-time call. Not everything needs to be done in 15 milliseconds, 40 milliseconds. Some of these things, frankly, should be done overnight or maybe even weekly. But so there would always be a call for them to get the result of what they did out of the case management system, out of that repository as well. And that would be the same for the modular loop hub. And that's just, this slide is just to show the interface. I'm not going to get into the details in that. So in this, we decided that the proxy and gateway models are not good. But the things we liked about the streaming model is it's a relatively simple implementation approach. It requires minimal integration between Actio, which is the name of the FRM product, DFSPs, and modular loop. Also, because of where it's placed, its ability to ingest the historical data as far as what's going on within the system is actually, it's in a good spot for that. But it really doesn't lend itself to doing interdiction. It would be difficult to do interdiction. The FRM solution, therefore, becomes more of a passive solution. So it's only generating information for potential follow-up, which may be immediate follow-up, but it's passive. And it also requires the hub operator, if we're operating in the hub, to install additional software, potentially additional hardware, configure the system, etc. The service model is more interesting because it is decoupled and works with any system via the API. It also supports the previously agreed to preferred method of semi-detached, right? So we decided in one of the other sprints that the semi-detached is really the best scenario because it provides that kind of centralized capability, but still leaves everything on the DFSP as far as the fraud risk management is concerned. And frankly, they're reliant, or they're the people that have to report to the regulators. It can support interdiction. It's designed to do that. Historical data is passed to us, and data for taking on the transaction is passed to us. And also within, we subscribe to data sources via various ETL methods. It requires the DFSP to install additional software and potentially hardware on their environment versus the hub. So it places that back out there more, and maybe with a central service provider that is also doing centralized shared services. So it works best with that scenario. To look at kind of the way we see this is there's tons of transactions coming at us, and we need to figure out what to do with it. So there's the data preparation side, which is standardization. We've got to work on how do we validate various things, the cleansing process, How do we transform the information into what we can use for what we need to do? And how do we enrich that information with additional information, additional data that we need to also make a good decision? And then how do we protect all this data as well? So once we get through that part, we actually have to do the rules processing and the typology processing. Inside that then comes the scoring, and these things are going on obviously in parallel. And then the decision of, on Moduloop in particular, do you interdict or not interdict? We know other systems will want to. We either interdict or we're just going into a passive mode for someone to respond to it after the fact. So back to this slide, and we'll talk through what's going on in a little bit. So we've got the API call into the system, and we're talking to NiFi first for what we're doing. There's actually a little more stuff going on there, but the reason being is we need NiFi to deal with all the data sources and give us well, really access to everything we need. It's a good streaming source, but right now, I mean, we're not set on this one. It's just one that we're working with. We like the data provenance side of it, the data governance side of it. It's all built in. It clusters well. It operates well at speed, and we'll talk about that some more in the performance portion. But it's obviously used in big data implementations and can scale, you know, quite large. We then feed it to Kafka. And in the middle, notice that we say engine, right? And the reason we say engine is because depending on what's going on, this could be a rule engine or this could be a typology engine. So the primary thing we're trying to do with this is use the appropriate technology that is fastest and best for a given thing. So we didn't go out there and say, we want a rule engine that covers this all, or even two rules engines that cover maybe say running generic rules and then running a typology assessment. We said we want to run each individual rule as quickly as possible, and then we want to run a typology assessment. So in some cases, that actually means the rule may very well be done in a couple lines of script incredibly quick, right? Which is what a lot of the ones that we've done here are. It could be that it's being done with a graph database. The graph database actually traverses all the different nodes and gives us back what we need so that we can then make an assessment. So we're keeping these things all very discrete. You know, we can change them, swap them out, and the idea is to make them replaceable. We do have a model that allows for complete pass-through. And what I mean by that is we've got block list in the middle there. But if you have a block list, you also need to have a pass-through list. So there are ways to add somebody to bypass that, and with reason, and deal with that on the scoring side. We also then, if you notice, there's data store, data store, data store everywhere. What we do to deal with fraud in this case, data is absolutely critical. So we've got these external data sources coming down and in. NiFi is helping us transform them into what we need and placing them, maybe doing aggregations on items that we're keeping in cache in Redis, which is something we're using right now. We're not sure that's what we stay with, but we're all comfortable with Redis, so that's what we're using in the PoC. But there's a lot of manipulation that goes on, followed by the scoring and then a push out through a proxy server, you know, for the results. But one of the things to notice is that there is basically a data lake up there by the part that says learning. And what that's for is for us to run retroactive tests on rules. It's for us to actually run machine learning tests to see if we're finding different anomalies. So that's what that whole learning area is about. How do we deal with everything we've been building up on the FRM and AML side, and how do we learn from that? The case management side, however, is the results, the metadata, the actions, what went on in the investigations or the reporting. So it is a source for that the API calls would go to and return to always check on what the status was of this item if it was flagged. All right, move on here. So we looked at a couple different approaches for processing rules. This is one I like, but it's very complicated. So in this scenario, individual rules fire once and only once. So if you had a rule 9 and you needed a new version of Rule 9, you'd have, you know, Rule 9 sub 1, Rule 9 sub 2, etc. But there's only one particular rule that, that exists in the system and that is fired in the system. It's fired once. And then there's a process for assembling those so that the typology knows which rules that it needs to be subscribed to, so that then it can evaluate them. And so a rule evaluates to a single determination. Then in the typology, because a individual rule component can have different weighting, different values, different meanings inside a typology. In fact, as a group of rules inside a typology, even that may be different. And I'll let Justice talk maybe a little bit more about that when he gets more into talking on the typology specifically. But then after those weights are assigned, we then score that rule specifically. And at the moment, we're pushing that back into Kafka. And then we also score it into, there's an additional scoring engine by transaction. So it may be that multiple typologies fired, and it may be that if say one fired by itself and came back bad, or two came back by itself bad, that's actually okay. But if 1 and 2 came back as bad, now that's a problem. So we have to allow for that in all these different flows. The problem, and I'll actually summarize that, is that this is a fairly complex model. It's one I put in, but only in very, very large systems. The topology-based approach is where you've got an individual stream or lane per typology. The rules will fire multiple times, and the rules then feed into the typology scoring itself. This is, whereas the pipeline is very normalized in structure, only having one of this and one of that in the relationship, we're denormalizing here, and you're doing so for speed performance, which is a common thing that's done. So we always knew that this was going to be fast. Again, I'll summarize some of the details in a minute. But this is the one that we actually went with for the PoC because it's easier to implement. So each rule runs within the typology, is evaluated, then again is evaluated with its own weighting based on the typology. The typology scoring happens individually, and again, then the entire transaction scoring occurs. So these are the two approaches that we believe pretty firmly in. The upside to the pipeline is, each rule fires once, it's efficient. The normalized structure really supports maintainability down the road, and it also, frankly, lends itself to the configuration layer very well, because it's you don't have to worry about somebody cloning an object and it getting out of control or things like that. The downside is it's really complex to build. There's a lot more orchestration involved, and the complexity requires a really complex design that can handle threading and parallelism, rule parameterization by topology. Actually, that one's in the wrong spot. That shouldn't be. Sorry, it doesn't have duplication unless what we want to do is say that there is a brand new version of, say, Rule 1. Now there is a Rule 2. So there is, in fact, duplication in that, but that's really an entire new rule that exists. We moved this to the MVP because of the complexity. We still want to see if we can make this because it has a lot of efficiencies. We're actually not sure that we can make it well and that will run efficiently or affordably. The typology-based approach is easier to build. It's denormalized, so it has the potential to be very fast, and it's actually proven to be very fast. There's less computational complexity. It's easier to do rule parameterization inside the typology, right? So actually inside the typology. The downside, of course, is that it runs the rules many times. So at scale, these additional resources may be problematic. That's unknown. It needs further testing. It's just like when you make the decision of, well, this takes a little bit more storage. Is it worth it or not? We need to understand the trade-off of that. Down the road, it will require extra work on the admin side and maintenance side to make sure that we don't start having issues with rules. One of the things that can be a problem is somebody, and I've seen this in real life, somebody makes a change to something or it gets pulled out of the natural flow of things as a rule, and then nobody realizes it's there. And so, changes or updates that are required by the regulator aren't being processed, then the regulator comes in for an audit, and that's a problem. Or even worse, it's real fraud. So we're allowing fraud to happen because of that. So we built this first, and because it was easier to do, and then we're going to continue to evaluate the performance versus scalability. And Justice, I'm going to give it back to you for your typologies and rules. Do you want to take back control? I don't think I'm going to have any more issues, but might be wiser.
Thank you. I have it here.
Okay, cool.
Thank you. So just a quick summary, I suppose. Typologies for us is the container within which rules operate. So a specific fraud risk typology might tell you how that fraud works. The rules is what you would apply to that typology to detect the typology in action. For the PoC, we picked 4 different typologies, and in addition to that, we also implemented basic block list processing as a typology, because it functioned pretty much the same way as a typology, using a rule to check if you're in a list and then providing a result of true or false. So from a block rule perspective, the difference between a typology and a block list processing is essentially negligible. The typologies that we selected, we wanted to pick something that was topical in a mobile money space, but also fairly recognizable. So SIM swap fraud, for example, is fairly universal and a very common thing. Scams as well. So any type of scam where somebody is trying to convince the customer to part with their money in some way through social engineering or, lottery fraud or prize winning fraud, those kind of things. Generally, those are categorized as scams, so we picked that typology. And then we also picked account muling. Are we able to detect whether an account is a mule account based on a number of different rules? And account muling is an extension of typically all of these other behaviors. So it's one of the vehicles that people use to defray the defrauded money as quickly as possible and integrate it back into the system. And then finally, we also picked money laundering, just normal, typical layering as money laundering as one of our typologies. The rules you see here, we've abstracted these to rule IDs only. We're now starting to get into the position where the information that we are building could be used against an operator or against customers. So we don't necessarily want to clue people into what sits behind all of our detection. We did pick a number of unique rules for each of these out of the overall set of rules. So there are more rules than just these 4, for example, to detect money laundering layering, but for being able to actually complete this work during the PoC, we downsized a little bit. There are 6 rules for typology 27, the SIM swaps, and 8 rules for typology 28 scams, and another 6 for account muling, and then blocker rules had its own specific rule. And you can see by the colors here that some of those rules are shared by some of these typologies. Obviously, in the typology-based approach, the overall set of rules here is effectively baked into the typology scoring result. So we are not executing rule 48 just once, we are executing rule 48 twice, once for typology 28 and another time for typology 14. The APRICOT model, here we are again. For some reason, we can never stop fiddling with the APRICOT model. We created a template that helps us to do a little bit more of the work. So our approach to the APRICOT model in this phase of the project was to operationalize it a little bit more. So some of the information here will be familiar. The APRICOT model over here gives us a visual representation of all of the attributes of a specific typology, in this case, typology 27. And there's the original summary that we were always familiar with. This is a fraud typology. In addition to this, what we've added here is a detailed description to explain how this typology is executed in the wild and how it could be witnessed. And we also applied or analyzed a mitigation and management strategy from the perspective of one of the actors within the network. So in this case, this is our perspective at the hub, and we identified a number of operational controls. Operational controls would be mostly implemented at the process level. So for example, 2-factor authentications on transactions, PINs, customer education, user education, all of those kind of things are operational controls that you can put in place in general to mitigate fraud in your organization. We also identified a transaction monitoring strategy for this typology, added a participant monitoring strategy for this typology. Sometimes the typology is all about the transaction. Sometimes it's about looking at the participant to understand who the person is who's transacting with you. And more often than not, it is a combination of the two. We also added all of the rules that could be used to identify this typology. So for typology 27, you can see here there are far more rules than the 6 that we had implemented initially. All of these rules together would then produce a scoring result. So the aggregated view is composed into a tree where all of the Boolean results, true and false, out of the rules are then interpreted, and a probability of this fraud being seen in the transaction that we are looking at the moment is then scored as a percentage. We've also cataloged all of the data that you would need in order to identify a typology. At this point, these are at the typology level, but you could probably break these down a little bit further because some rules need some of the data and some other rules need other pieces of data. Not everything necessarily needs all of the data for a typology. So as in a particular environment, if some of the data isn't available, that may disqualify some of the rules and then would hamper your ability to detect that kind of fraud. But you'd know that because we would have a data dictionary that's linked to each of the rules, and we would then have to adapt and calibrate the scoring according to your capabilities and what data you might have available. Each rule could be configured according to a number of parameters. So we have default values for those that we use for the PoC, but in the long run, through business intelligence, MIS, or even machine learning, we should be able to calibrate these rules to come up with the parameters that would make most sense in a specific environment. Not every installation is likely to be the same. So even for a implementation, you may want to calibrate your rules to match that particular implementation. And that is also something that we added to the APRICOT model. One of the big challenges that we had is it's easier to find the needle in the haystack when you put it there yourself, but that doesn't really test your system's ability to find the needle in the haystack. So what we needed to do was to create synthetic data, but data that was realistic in a way so that it would model real-world behavior. And we needed a lot of data because not only did we want to test whether or not we were able to trigger our rules as we expected, but we also wanted to test that our rules were able to be performed at pace. So from a performance perspective, we wanted to feed millions and millions of transactions through the system. From a fraud perspective, you can't copy paste those transactions because we actually have rules that check whether or not data is being synthesized. So if we create artificial data that looks like artificial data, then we'll trigger all of the wrong rules that looks for artificial data. So this for us is a very big challenge. We've been working with, if you saw Rob's presentation yesterday, we worked with the FCA and we used some of the learning that we had made in that project to understand how we could potentially synthesize realistic data in mass. And we made quite a lot of progress towards that. We synthesized 1 million records, realistic data, customer records, and transactional data for the purposes of testing the performance, which you will see shortly. And as I mentioned, the challenge you have here is you run out of unique data very quickly. So if you are trying to test at 10,000 transactions per second, which is our actual stretch target, because where we started off saying we wanted to test for 3,000 transactions per second, the general view was that that would be the average and you would have to be able to burst beyond that. So we actually need to be able to test all the way up to 10,000 transactions per second. But that's 600,000 transactions per minute. And if you want to run a test for an hour, then you would need 36 million unique transactions that have fraud hidden in them somewhere that you didn't put there yourself, because otherwise you'd know how to tell your system how to find it. So this is work that we see continuing in the next PI as well, and something that will probably be a part of the project on an ongoing basis, because the more rules we develop, the more typologies we implement, the more our need for specific data will increase. And now I'm going to hand over to Johannes Foley, who's going to give you a quick demonstration of what we built. Over to you, Foley. I'm going to stop my share.
Hello, everyone. I am Johan Foley. I'm a developer that developed part of the PoC for FRM. So what I'm going to be showing for us today is a batch of transactions that we have that should trigger most of the rules of the different typologies that we have. So I'll just show us a real time of all of the slides that we've seen before this. So the role of Postman in this is to basically show the handoff of transactions. So it's simulating what Mojo Loop would do to the FRM system. So I'm just going to go ahead and start that. Then I'm going to swap over to our Kibana dashboard. So what we can see here is all of the different typologies that Justice just mentioned. And what we should see happening is that some of the rules will start processing. And then we should see the outputs that the different transactions reached. So what we can see for typology 214, we can see that some of the transactions had a score output here of 0.4. And the reason for that is because Rule 12 and Rule 78 was triggered. We can see here's another transactions that reached a score of 0.2, the reason being only Rule 12. And then there's some of them that reaches 0.6, which would be 60% score, because it reached 12, 48, and Rule 78. For all of the different typologies, we can see all of the different rules that's being triggered. So for 11, typology 11, we can see here that Rule 86 and 87 has been triggered. So this is a possible money laundering for layering that we can see. And then for typology 27, we can see that there's some of the transactions that scored 0.2, 0.4, and 0.6, as well as some that didn't score anything. So that's the breakdown of the different rules being triggered in all of the different typologies and the scoring happening. So for all the different weights of the different rules. Then the next piece of information that we can see here is the latency per typology. So when we started with the PoC a couple of months ago, we had a goal, and that goal was to process 1 million transactions in a 5-minute period at a 35 millisecond delay on average. So what we can see in this graph is we can see the average processing time for the different typologies on all of the transactions submitted. So what we can see here is the longest process, the typology that takes the longest to process is typology 11. One thing to note is that all of these typologies are running in parallel. So with other words, as soon as typology 27 is finished, it's finished. But the final scoring can only happen once all of them are done, which means it was a wait of 25 milliseconds, which is well inside of the 35 milliseconds that was the aim. So on this point, I'll hand over to Jason, who's going to show us some of the load test results.
Thanks so much for the introduction, Jan. Good morning, afternoon, good evening, to whichever time zone you may be in. Greg or Justice, if you don't mind sharing the slides, I can talk through it. Okay, perfect. Thank you, Justice. Okay. I think what I would like to do today is take you through some of the performance metrics that we captured during our PoC testing. So as Johannes discussed, one of our sort of driving goals in the PoC was to see, can we ingest 1 million transactions within a 5-minute period? So one of the things we looked at is, okay, it's great, we're ingesting transactions, but we don't really know how fast each topology is in this load test. So one of the things we went out to do was ensure that we understood what our average TPS is at load per topology. And we started seeing some interesting metrics. It's worth mentioning at our peak in terms of load, we were touching at about 8,000 TPS. But as Foley described, your slowest topology is your slowest result. So we sort of determined by this that our TPS rate was about 5,500 TPS. That was based on the slowest topology we had at that point in time. And the load test also raised something to us. Some of the findings that became apparent from the load test were we need to have telemetry integrated into our platform sooner rather than later. As we were running through the load test, we started feeling the bottlenecks as they appeared, and it wasn't immediately obvious where the bottlenecks were coming from. One of our first steps was NiFi, and we encountered, I think, what some may be familiar with as the Stop the World garbage collection in the Java JVM. So once that was our bottleneck, we had to tune past it. At that point, once we scaled NiFi, and I'll go into some of the specs of what our environment looks like. Once we scaled NiFi, obviously, as everyone would expect, the bottleneck moved. The bottleneck moved to Kafka. We scaled our Kafka. We added partitions. We moved the bottleneck along. So I think what I'm really trying to state is, even if in a POC, I think it's really important that you get your APM, your application performance metrics, up as soon as possible, because it saves you a lot of time having to go through things. In regards to the hardware, I don't have it in this presentation, but I can give an idea of what we're running, and I can just give you node counts. To achieve these metrics, our NiFi cluster had 24 nodes. Our Kafka was only 4 nodes. Kafka was the most performant piece, of the tools that we picked up to use in the POC. Elasticsearch, just to keep up with the ingestion, is 6 nodes. And our topologies are running 3 instances of each. What also became apparent is the Kubernetes default load balancer, the one that it ships with, wasn't acceptable for us to use in terms of our load tests, because our topologies never peaked on CPU and RAM. So we had to do some investigating. What we did notice is there was no effective mechanism for the default autoscaler to scale our topologies. And coming out of this, one of the things we're going to be looking at is the open cloud native foundation project known as KEDA. KEDA is an event-driven autoscaler. So it's going to give us the capability to scale based on topic lag. So that's something that hopefully by the next convening and the next performance test, we'll be able to demonstrate its effectiveness. 2 other points that I'd like to mention regarding the performance test is we are going to look into compression of messages going to and from Kafka. We will evaluate GZIP, and I believe the other one on our radar is Snappy. We're also considering moving away from JSON as our message structure. We plan to evaluate both Avro and Protobuf to determine if there is a benefit, especially as we continue to try reach new limits in the scaling. And I think from my side, that's it.
Do you maybe just want to go through the to-do list for us in terms of the improving the performance, Jason?
Okay, so yeah, I mentioned it, I think, at certain points, but we have to spend time optimizing our Java components because, as I said, where we didn't expect to hit performance issues, the garbage collector made sure we did. As stated, we're going to look into KEDA, which is an event-driven autoscaler for Kubernetes. And defining telemetry is really going to be an important step for us in the next scope of work. And obviously the JSON, or not to JSON, and message compression.
Great, thank you very much.
Thank you, Ron.
And then just to wrap up from our perspective, we have a number of things that we need to do. So we have to address in our very next sprint graph-capable rules engine. A couple of the rules that we did deploy, we feel we fudged a little bit through a relational database implementation. It would probably have been better served as a graph database to manage the networked nodes within that specific query. We also have to look for a performant historical data store. A lot of our transactions, due to the nature of the PoC, are more cached than persisted. We need to, in the long run, it would be necessary for us to go and retrieve that information out of a data store, or data lake, or data warehouse, or something like that, that can perform at the pace that we need it to support the throughput we want for the rules. We also need to build a schema or a framework for rules configuration management and change control. So that has to be rolled out as part of our MVP solution, but we want to get ahead of that and do that early. And then there's the question around typology and rules orchestration. So if we spin up a typology that needs to evaluate a specific transaction, how does the typology know which rules result to expect? So there has to be some kind of orchestration that manages the milestones through the evaluation process so that everybody gets the information they want and that nobody moves on without having completed the work that they were supposed to do. And as Jason mentioned, there's a number of things that we still want to look at on how we can improve performance. I think the team really blew us away with their with the solution and the performance that they were able to achieve. We thought that when we posted a 3,000 transactions per second target, that would be a very big number. The team actually made that look very easy. We left that number in the rearview mirror quite a ways back, and the team did a phenomenal job on getting the performance up to the level where it's at. If we can tweak that performance and we can improve it even more, then we can rest assured that there won't be a bottleneck in the solution in terms of performance, at least. And then for the first PI, we are probably looking at answering that realistic data synthesis question. Finding data that is realistic, that actually tries or utilizes the information that we want to evaluate for the rules, that matches the typologies, and then also triggers the rules. That's going to be important for us to ensure that the system functions the way that it is intended. If we are just providing data that matches our test cases, then we are effectively marking our own homework. From a fraud risk perspective, that's probably not going to be good enough. In addition to that, when we start rolling out the rules for the fraud risk management solution in the MVP, we need to have a mechanism where we can calibrate the rules. How do we configure them? How do we parameterize them? Which typologies need how much of a specific rule? If you consider that a typology may have 20 rules in order to detect it, the net percentage contribution of any typology on average is about 5%. How do you ensure that you get a sensible result out of the typology probability with so many rules going into the evaluation in the first place? We also have to answer questions now about security and privacy, security of the solution, unauthorized access, and so on, but also privacy of the data. We are working with customer data. That's something that typically, from a modular perspective, I don't think the solution has to be too worried about, because most of the KYC information is still within the purview of the DFSP. To be able to effectively detect fraud, we need access to that information, and that makes us responsible for the best kind of privacy that we can implement. And then finally, we want to encourage increased community participation here. We have been working, I suppose, as a team for the last 2 or 3 months very closely together to bring the PoC itself up and running. But we'd like to encourage more participation from wider in the community, and we'd like to discuss what shape that will take. When we started this PI, I think one of the things that we found very valuable was having a workshop at the beginning of the PI where we discussed our requirements. We took in contributions from the community and needs, and that helped us to shape the project for the next 3 months. And I think that is something that we would like to do again. So if you are interested in participating in that, please do let us know, and then we can invite you to our scoping workshop and our requirements elicitation so that we can make sure that we are adding you into our backlog, and also to look for ways that you could contribute and support the project in the long run from a modular perspective. One of the things for that is because we are working with very sensitive information now, and we are getting into the nuts and bolts of how to detect fraud, and also, in other words, how to perpetrate fraud. We would have to look at some sort of secure onboarding and sharing of work and information protocol to make sure that we don't leak information that could be used against our clients in the long run. And that, I think, is us. Thank you very much, everybody. It was really great. So, Greg?
Yeah. Sorry, I just wanted to add one more thing. I've been blown away by the performance. We probably used a little more hardware than we had initially thought, but we also didn't think we were going to get to this. And to be honest, even what we used wasn't bad. So I see people asking about what did we do to get there. The thing I want you to realize and keep in mind is this was a POC. Major portions of this were just getting infrastructure in place and getting how we were going to all work together going and things like that. So the amount of work that we managed to produce in this one PI, I'm particularly proud of everybody and the job they did. And I'm really looking forward to see where we can get this performance, because we've been talking to other, the goal at the beginning was that 3,000 transactions a second and 35 milliseconds on a response. Now, we've been talking to other people who need to be running at 20 and maybe needing to be able to peak to 30. So we've got more work to do here. But I'll leave it with that because I know Simeon needs time back.
Great. Well, thank you very much, everybody. If you do have any additional questions, I know we've been fielding questions out of the chat, but drop your questions into the Discord. We will be monitoring the Discourse. We'll be monitoring the conversation there and responding in the Discourse as well. Thank you once again, and we look forward to continuing this work with the community over the next 3 months. Take care, everyone.
Awesome. Thank you so much, Justice, Greg, and team.